Okay, so question number 12. Is hydrogen cyanide polar or nonpolar? Okay, so first let's find out the Lewis structure. So we need to calculate the total number of valence electrons in this molecule. So hydrogen contains 1, carbon contains 4, and nitrogen contains 5. So this gives us a total of 10 valence electrons. And now let's try to draw a reasonable Lewis structure. So hydrogen is a terminal atom because it can only make a single bond. And carbon is less electronegative than nitrogen, so it is going to be our central atom. And for it to have a full octet, I'm just going to draw out triple bond between the carbon and the nitrogen, with the nitrogen having an extra lone pair. Let's count out all the electrons I've drawn. So each bond contains 2 bonding electrons, and we have 4 bonds. So we have a total of 8 plus 2, which is 10. So this is a reasonable Lewis structure for HCN. So now let's calculate and see the difference in electronegativity between both carbon and hydrogen and carbon and nitrogen. So this will help us find out whether the molecule is polar or nonpolar. So the electronegativity difference between carbon and hydrogen, so these are the different electronegativity values. Carbon is 2.5 and hydrogen is 2.1. So this gives us a difference of 0.4. And now let's do the same thing for the carbon and nitrogen bond. So carbon is 2.5 and nitrogen is 3. So it is slightly more electronegative than the carbon-hydrogen bond. So I'm going to show a dipole moment pointing towards the direction of the nitrogen. And because we have a non-zero dipole moment, then this means that this molecule is polar. So since there's a net dipole moment that is not equal to 0, HCN is a polar molecule. So this makes the side containing nitrogen to be partially negative and the side containing the hydrogen to be partially positive. Okay, so let's see what the junior tutor said. Polarity refers to the charge separation which causes the presence of dipole moment. Additionally, polarity can be viewed from the perspective of a bond or the entire molecule itself. A bond can be polar if the electrons are unequally shared between the bonded atoms. Mainly, this is due to the electronegativity difference, about 0.4 to 1.7 of the atoms. However, although a molecule has polar bonds, this does not imply that the entire molecule is polar. If the molecule's symmetry results in the cancellation of the dipole moments, overall the molecule becomes nonpolar. So to determine if the molecule is polar or not, first let's check if it has polar bonds. The carbon-hydrogen bond is nonpolar because the difference in the electronegativities between the two atoms is only 0.35. So they used a much more accurate electronegativity value chart. So that is correct. And on the other hand, since carbon and nitrogen have an electronegativity difference of 0.49, we can classify it as a polar bond. Since there's only one dipole moment pointing towards nitrogen, nothing would cancel this out. Therefore, HCN as a molecule is polar with a net dipole moment to the right. Yep, so this solution is correct.